So today we're going to look at lesson 13-5. We are going to graph sine and cosine functions, which are waves. So first and foremost, a periodic function are functions that repeat exactly in regular intervals called a cycle. And then we are going to call that cycle a period, because trig functions are periodic. So the length of a cycle is that period. So let's highlight that. The length of a cycle is your period. And then your amplitude, which if you kind of think about the amplitude in terms of like a triangle's amplitude, is the height of that triangle. So that same thing here, the amplitude is the height of the sine wave, and it's really only above the zero line, which in this particular case is the x-axis. You'll find out later that the zero line can change, but for right now we're only going to look at period changes and amplitude changes. So the period of this particular function could be from here to here. So this is going to represent one period, so I'm going to highlight that. So right here is one period. And then your amplitude is the distance that, like this is the lowest value of this function, and this is the highest value of that function. So your amplitude is halfway between those. So it's from the zero line down, or it could be from the zero line up. They should be the same distances. So your amplitude goes from here to here, from those places. And then the other thing that we're going to look at is called key points. So key points are where your graph, it's not necessarily where your graph turns, but they're the places on your function that you want to pay attention to. And I'll explain where these key points come from. But on this particular graph, the key points are here at the height of the amplitude. Then it always goes back down to zero, then down to the lowest point, back to zero, and up to the highest point. So I'm going to put ordered pairs here. So that's going to be a key point. This is going to be a key point. I'll show you how to find them. Key point, and key point. All right, so let's start by looking at the sine function. So in order to graph the sine function, we are going to look at the unit circle. So you've got to use your unit circle values. This x-axis right here is going to represent the angle in standard form, and you'll notice that it is always 99% of the time in radians. And then this y right here always represents the corresponding trig value. So, you know, at this value, pi over 2, what is the sine value of that angle? So we specifically like to look at values on the unit circle that we're familiar with. So I'm going to draw not the unit circle per se, but the axes for that. And so if you will recall, this is 0, this is pi over 2, that's pi, and you are expected at this point, of course, to know those values, and 3 pi over 2, and of course we finish up here again at 2 pi. Then let's look at the ordered pairs at the north, south, east, west axis points. So the ordered pair at 0 and at 2 pi is 1, 0. The ordered pair at pi over 2 is 0, 1. Ordered pair at pi is -1, 0. And the ordered pair at 3 pi over 2 is 0, -1. And the reason why that's important is, remember that the x value of each of these ordered pairs represents the cosine of 0 and 2 pi, and the y value represents the sine of 0 and 2 pi, because remember, this is the angle measure, it's in radians, and then the ordered pair represents the value of that trig function at 0 and 2 pi, or over here at pi over 2. So let's go ahead and label these as cosine, sine, cosine, sine, cosine, sine, and cosine, sine. So when we look at the sine graph, we are only going to focus on these 5 points, because technically there's 2 points here, so that's where our 5th point comes from. So I'm going to go here from 0 all the way to 2 pi, and then we'll fill out this left part following the pattern of sine. So you don't have to memorize the pattern of sine if you know your unit circle. So let's think about this. We're going to assume that we have an amplitude of 1, and you can tell where the amplitude is because it's the number that's in front of the trig function, and since there's no number here, it's understood to be 1. So our amplitude is going to be 1, and our period is going to be a normal period of sine. And a normal period of sine is from 0 to 2 pi, which has a distance of 2 pi. So if I go from 0 to 2 pi, that's a distance of 2 pi. So that's how long my sine wave is going to be. So the other thing we're going to talk about are key points. So key points you need to have 5 key points when you plot your period. Now, all of these graphs are labeled the same, so as we stretch a period out really, really long, we may not actually get all 5 of these key points in, but we're going to try our best. So your key points are determined by taking the period whatever the period is, and in our case right now it's 2 pi, and you will always divide it by 4. So in our case here, our period is 2 pi, and so we're going to take 2 pi and we are going to divide it by 4. So 2 pi divided by 4 actually equals, if I reduce that, 2/4 is 1/2. So I really have pi over 2. So our key points are going to go, we're going to count by pi's over 2. So our first key point 100% of the time is always going to be 0. So 0 is always our first key point no matter what. Then you're going to add what you're counting by. So I'm counting by pi's over 2. So I'm going to add a pi over 2, which equals pi over 2. So that's my second key point. Then we're going to add another half pi, and that's going to give me my third key point. So 1/2 and 1/2 is 1 pi, and then we're going to add another half pi to pi. So if I have pi and I add another half, that's 1.5 pi, which as an improper fraction is 3 pi over 2. And then we're going to add, so that gives us 4 key points. I need one more. I'm going to add another half pi, and our final key point, 1.5 plus a half, gives me 2 pi. And so when you look at a standard trig function that has a normal amplitude of 1 and a normal period of 2 pi, then you're going to always be seeing these key points. So if and it's really not necessarily about the amplitude, but it's really more about the period. If your period is the normal period of 2 pi, then you will always have these 5 key points: 0, pi over 2, pi, 3 pi over 2, and 2 pi. And you'll notice that they go by the north, south, east, west axis poles of the unit circle. And that's where we get these key points from. So I'm going to look at the unit circle at 0 and see what the sine value is. I'm going to look at pi over 2 and see what sine is, look at pi, 3 pi over 2, and 2 pi, and figure out what the sign value is on all of those, which we have done by looking at the ordered pairs here. So I'm going to highlight as I go, but let's start with 0. So if my first key point here is at 0, and I'm going to go ahead and mark on here my key points so that I know where I have to move. So I'm going to put a little mark here at 0, pi over 2, at pi, I'm just putting hash marks, not ordered pairs, 3 pi over 2, and 2 pi. So those are the 5 places that I'm going to look to put an ordered pair. So let's start here at 0. At 0, I'm looking for a different color. At 0, notice that my sign is 0. So at 0, I am going to have an amplitude of 0, because, let's go through that again. At 0, right here at 0, the value of the trig function is 0, so I only go up to 0. Then at pi over 2, let's look over here. At pi over 2, my sign here is 1. So at pi over 2, I'm going to go up 1, because notice these are going by, they're going by ones, but they're only labeling every other one. So here's at 1/2. According to the unit circle, the sign value at 1/2 pi is 1, right? Right there is 1. So we're going to plot the point at 1. And then you're going to notice we're going to end up going back to 0, because watch. So at pi over here, pi isn't sign 0, as I told you. We were going to go back to 0. So let's plot a point at 0. And then our next key point is at 3 pi over 2. So over here at 3 pi over 2, notice that our sign is now -1. So we're going to dip below the x-axis and plot a point -1 down. So there we go. And then our final key point for one period of sign, which has a distance of 2 pi, we're going to look at 2 pi. So at 2 pi, which is the same as 0, sign is back again at 0. Whoops, that's not what I wanted. Here we go. So now I'm going to connect these points with a red line, just so that you can always see that's one period of sine with a normal amplitude of 1. And you can see that at the highest point here, it's a distance of 1 away from the x-axis. And at the lowest point, it's a distance of 1 away from the x-axis. And it has a period of 2 pi, and it goes from 0 to 2 pi. So that is a length of 1 period of the sine wave. Then we can follow that pattern. Notice that the pattern goes from 0, up 1, 0, down 1, back up to 0. So every other point is 0, and then we go up 1 and then down 1 on every other point. So if we go backwards, well, we were already up over here, so when we go to 0, we're going to go down 1. And I'm counting by half pi's, right? Because that is my key point distance, is every half pi. And fortunately for us, these are all labeled every half pi. So I'm going to go ahead and label my points for the rest of my sine wave, because you need to fill out the entire graph. So the one to the left, I'm going to go down to -1, then back up to 0 at -pi. Then at -3 pi over 2, I go up to 1, and at 2 pi, I go back down to 0. So notice again, every other point is 0, and here I went up, so here I go down, and here I go back up. So it goes 0, down, 0, up, down, and the next one would be, or at 0, next one would be down. So I'm going to connect these with a purple line. And so that is a normal sine curve. We will manipulate the amplitude and period later, but let's talk about cosine. So cosine, we're going to do the same exact thing. And we have the same exact key points, because Cosine also, a normal cosine curve, also has an amplitude of 1 and a period of 2 pi. So we are going to, let's see, I'm going to put hash marks here at our key points: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Because we have a period of 2 pi, we're still going to take 2 pi and divide it by 4, and we still get pi over 2. So we're still getting these same key points. So anytime your period is 2 pi, you are going to have these 5 key points, which are the same points as the north, south, east, west axis poles. All right. However, notice that the value at these angle measurements is different for cosine. So look at the x value. Instead of being at 0 where sine was, we start at 1 when the angle is 0. So right here at 1, we are going to go up to the amplitude. The amplitude is 1. So right here we're going to go up to 1 and plot our first point. Just like the sine curve, every other point is going to be 0. And let me highlight. So notice here your cosine was 1, and that's why we went up to 1. So now we're going to go to pi over 2. So at pi over 2, notice again that cosine is 0. Like I said, every other point is going to be 0. So we're going to plot at pi over 2 a point at 0. Then at pi over 3, I'm sorry, at pi, those are so tiny I can't see them. So at pi, we're going to go over here. Notice at pi, the cosine value is -1. So at pi, we are going to go down the amplitude to -1. Then we're going to go look at 3 pi over 2. So over here at 3 pi over 2, cosine is 0. So we're going to plot a point at 0 at 3 pi over 2. And finally, our last key point is at 2 pi. And so at 2 pi, we're back again up at 1. So the cosine, and the reason why I like to do just one period at first is because you can see there's a visual difference between the cosine wave and the sine wave. The cosine wave starts up. So the cosine wave actually looks like an upside down bell curve. So it looks like this U, whereas a sine curve looks like an S. S for sine, sine curve, sideways S. And then your cosine just looks like an upside, or I guess it looks like a U, but it's an upside down bell curve, to be honest. But you can see here with a cosine, you've got that pattern up, 0, down, 0, up. Whereas sine is 0, up, 0, down, 0. So learn your pattern, because we're going to follow this pattern for cosine on over here. So if we were up, we're going to go down, and notice we're counting by half pi's again. So if we went up, we're going to go down to 0, then down to -1, then back up to 0, and back up to 1. So let's lay our other points down. So at -1/2 pi, we're going to be at 0. Then at negative pi, you have to go down to -1. At -3/2 pi's, you're back up at 0. And at 2 pi, you're back up at 1. So I guess this side should be going down. That's an arrow. There we go. Okay. So those are your normal sine and cosine. So let's talk about what happens if we change the amplitude or the period. So here you can see that if you have a number in front of the sine function or in front of the cosine function, we're going to call this A. A is going to represent the amplitude. And we want to look at the absolute value of A, because sometimes A is negative. If A is negative, it causes a reflection. Now you're not going to see a negative A today. We're going to hold off on that. We're just doing the beginnings of of sine and cosine, so baby steps. And then if you have a value in front of your angle measure, theta represents your angle measure. So if you have a number in front, here or here, that's called B. And B is going to affect the period. So the period is going to end up being 2 pi. And then you are going to divide by the absolute value of B. So that will stretch or shrink your period. Your normal period is 2 pi. So if there is a number in front of theta, you're going to end up dividing that into 2 pi. Then that becomes your period. And since that becomes your period, then don't forget that you're going to divide that by 4 to get your 5 key points. So let's just look at these two questions here. So with this first one, notice that the 3 in front of the sine function represents the amplitude. So the amplitude is always really easy to find. So this graph is going to go up to 3 instead of up to 1. You're going to go all the way up to 3 or all the way down to -3. But your period now has this 2 in front of theta. Theta is representing your angle measurement, whatever it might be. So to determine our period, and I'm going to do the work kind of here down below, I'm going to take the 2 pi and we're going to divide it by the absolute value of B. You're not going to get a negative value for B right now, but we're just throwing in that that's what it needs to be. So we're going to take 2 pi and I'm going to divide by this value right here, which is 2. So if I take 2 pi and divide it by 2, the 2's cancel and I end up with a period that is pi. So our period here has been shrunk. Now to find your key points, I'm going to go ahead and show you how to find the key points given a period that is pi. So for our key points, so your key points, you're always taking the period and you divide it by 4. So in our case, our period is pi, and we're going to divide it by 4. So that means we're going to count by 1/4 pi. 100% of the time you start at 0, so our first key point is going to be 0. And then we're going to add pi over 4 every time. And I don't care if you reduce these fractions. That's fine. It's easier when you're graphing to not reduce them, to be honest. So then your next key point is pi over 4. So now we have 2 key points. And then plus pi over 4. That equals, drop my pen, sorry. That equals 2 pi over 4, which is pi over 2, but we're going to leave it 2 pi over 4. And then we're going to add pi over 4. And that equals 3 pi over 4. So now I have 4 key points. I need 1 more. And so then we're going to add pi over 4. And that gives us 4 pi over 4, which of course is pi. So notice that the distance between my lowest key point and my highest key point, so if I took pi and subtracted 0 from it, I do get a period of pi. So essentially we've taken this period of pi and cut it into these key points that are going to represent how my pattern is going to go. So with sine, remember sine starts down at 0 because the value of sine at 0 is 0. So at this key point you would be down at 0. Then the next key point you're going to go up to the amplitude of 3, then back down to 0, then down to the amplitude of 3, so at -3, and then back up to 0. We'll graph some here in a minute. All right, look at number 2, and we're going to do the same thing. So again, the amplitude is very easy to find. It's the value in front. Was that one a sine? Okay, good. Both of these are sines. For some reason, I thought they were different. All right, so the amplitude on this one is 3/2, which means you're just going to go up 1.5 and down 1.5. And then your period, we are going to take, I'm going to do the work a little bit over here to the side. So I'm going to take our normal period of 2 pi, and we are going to divide it by this value right here. So that value right here is that 1/3. So I'm going to divide it by 1/3. So remember, if you have a fraction and a fraction, we are going to keep, change, flip. So we're going to keep the 2 pi over 1, and we're going to change division to multiplication, and we are going to flip the 1/3, and it becomes 3 over 1. And so we get 2 pi times 3 is 6 pi. So our period becomes 6 pi. So we've now stretched our period from 2 pi all the way to 6 pi. All right, so that's pretty far. So let's find our key points. So our key points, and I like to write KP, it shortens things up. So we're going to take our period, our new period of 6 pi, and we're going to divide it by 4. So 4, I mean, it does go into 6, but I'd rather reduce that fraction. So 2 goes into both of those. So 2 goes into 6 3 times. So I get 3 pi. 2 goes into 4 twice. So we are going to count by 3 pi's over 2. We start with 0 100% of the time. So our first key point would be 0. And then we're going to add 3 pi over 2. So our next key point is 3 pi over 2. As you can see, we're jumping pretty far ahead. And then we're going to add 3 pi over 2. So our next key point is going to be 6 pi over 2. That gives us 3. Add another 3 pi over 2. And we get 9 pi over 2. And add 3 pi over 2. And we'll get our last key point, which is 12 pi over 2. Now 12 pi over 2 reduces to 6 pi. So the distance from 0 to 12 pi over 2 is 6 pi, which is our period. So you always want to double check that. So again, because it's a sine function, at 0, we're going to start at 0. And then at 3 pi over 2, you're going to go up to the amplitude of 3/2, which is 1.5. Then the next key point, you're going to go back to 0. At the next key point, you're going to go down 1.5, which is at 3/2. And then at the last key point, you'll be back up at 0. So let's try that. So flip your paper over and let's do 4 different examples. Then I'm going to have you do the other 4 as your homework. All right, so I'm going to make these, really big, so you can see what I'm doing. Okay, I'm going to save the part on the left so if I have some work. All right, so our amplitude for this sine function is the 4 right here. That means we're going up to 4 and down to 4. And then our period is going to be a normal period of pi because there is nothing in front of theta, or normal period of 2 pi. So if it's a normal period of 2 pi, our key points have not changed. So our key points from what I told you on the front are going to be 0, pi over 2, these are the north, south, east, west axis poles, pi, 3 pi over 2, and 2 pi. So those are the 3 things you've got to find before you ever start graphing. So then I'm going to go on the graph itself, and you can see that all of these graphs are already labeled for you. They basically go by quarter pies, but they're labeled every other thing. So we are going to do these 5 key points. So I'm going to label those on our graph as hash marks just so you know where you have to lay your ordered pairs. So those are our key points. So I'm putting purple hash marks there. And then you're going to look at the sign value at each of those points. So think of the unit circle. So remember, at 0, the sign value at 0, that ordered pair is 1, 0. The y value 0 is the sign value. So that's why we're starting down at 0. For the sign function, we always start at 0 for sign. Then your next key point, which is pi over 2, we're going to go up to this amplitude here of 4. So at pi over 2, we're going to go all the way up to 4 and place our next ordered pair. And then our next key point, we're back to 0. So remember that pattern goes 0, up to 4, 0, down to 4, back to 0. So 0, up, 0, down, 0. So our next key point is 0. Our next key point will be down to 4. And our final key point is back to 0. So you see this nice S curve. Whoops, I missed it a little bit. Forming. And so that is one period of 4 times the sine of theta. And we're leaving all of these graphs labeled identically so that you can see how the amplitude and period changes the shapes of these graphs. So then we want to finish that same pattern over here to the left. And I'm not going to put the purple hash marks here because they're already labeled for me. But I'm going to continue that pattern but going backwards. So if I was already at 0 here, then the next one I need to go down to 4 because the previous point up here I was up. So I go 0 and then down. So I'm going to go down to 4 at negative pi over 2, back to 0 at negative pi, up to 4 at negative 3 pi over 2, and back to 0 at negative 2 pi. And so then this represents the rest of the graph's sine curve. So yes, you do have to fill out the whole graph. Okay, so then let's move on to question 4. So question 4 is cosine. And if you look at what's in front of cosine, there's no number here. So that means the amplitude remains the normal amplitude of 1. But we have a period change because there is a coefficient in front of theta. So to get our period, I'm going to go off here to the side. And I'm going to take 2 pi. And I'm going to divide it by this value here, 1/2. So that means that I got to keep change flip. So 2 pi over 1, instead of division, I'm multiplying, and I'm going to flip the 1/2, and I end up with 2 pi times 2 is 4 pi. So my period is 4 pi. So before I can graph, I have to find my key points. So let's find our key points. So KP, we're going to take that new period of 4 pi. So we always take the period and divide it by 4, always 4. So in our case, we are going to be counting by pi. So always, your first key point always is 0. So we're going to start with 0, first key point. Whether it's sine or cosine, we always start with 0. Oops. And then I'm going to add pi to that. Now, because our graph does not go out to 2 pi, you're going to note that we're not going to get all these key points on there. So then our second key point is pi. And then we're going to add another pi. So then our third key point is 2 pi. Add another pi. because we need 5 total. We get 3 pi. And then we're going to add another pi. And we finally get 4 pi. You always want to do your 5 key points, even if they're not going to fit on the graph, because you want to make sure that your period of 4 pi in this case, that these key points represent that distance. So to go from 0 to the largest key point is a distance of 4 pi. From 0 to 4 pi, distance of 4 pi. So we always have 5 key points even though we divide it by 4. Okay, so I'm going to take, now is kind of important because we no longer are counting by half pies, right? So these are not our markers for going up 0, down 0, that type of thing. So I'm going to put purple for my hash marks for my key points that do fit on this graph. So I definitely want 0. And then the next one is pi. So here's my next. It kind of gives me a line of sight of where I want to go. And then the only other one I can fit on here is 2 pi. So we're only going to get a half a period on the right, but then we'll get a half a period on the left too. So remember for cosine, cosine always goes up to 1 because at 0, the value of cosine at 0 is at 1. That ordered pair is 1, 0, cosine being 1. And the amplitude here is 1, so we are going up to 1. So I'm going to plot that point here at 1. Then the next key point, if we were up at 1, next key point is at 0. So we're going to go to 0. And then our next key point, if we were up before, now we're going to go down to 1. So I'm going to plot down. So this one looks like and that's half of our period for cosine, because remember cosine normally looks like a U, and so you've got this left side of the U forming, and the right side would go up like this, right? But we're going to go in this direction and follow that same pattern. So I'm going to continue with my purple lines to kind of remind myself. So if I'm counting by pies, my next one's going to be at negative pi and then at negative 2 pi. So if I started up at 1, my next key point is going to be to 0. So 0, and then my next key point is going to be down 1. So connecting these. There is our cosine function. As you can see, that period of 4 pi is really stretched out that graph. It kind of looks like an upside down cosine because we only have the left half on this one and the right half on that one. All right, let's look at another one. So number 5. So number 5, we have both an amplitude change and a period change. So our amplitude is that number in front of the trig function. So in this case, our amplitude is going to be 1/2. That means we're going to go up 1/2 and down 1/2. Let's find our period change. So to get our period change, we're going to take 2 pi and divide it by the number right here that's in front of theta. So we're going to divide it by 3. And so our period, we have nothing to reduce, is 2 pi over 3. I really dislike counting by thirds, so this is going to be fun. All right, so let's find our key points. So our key points, remember we're always going to take our period, so our new period is 2 pi over 3, and we're going to divide that by 4. So we're going to keep, change, flip. 2 pi over 3 times the reciprocal of 4 is 1/4. So I can cross reduce, 2 goes into 2 once and into 4 twice. And so I end up with a key point, I'm going to count by, let's see, 1 times 1 times pi. So I've got pi over 3 times 2 is 6. So we're going to count by pi's over 6. So we're going to always start with 0. So that's our first key point. Then I'm going to add pi over 6. That's going to equal pi over 6. Going to add another pi over 6. And that's going to equal 2 pi over 6. And I'm going to add another pi over 6. And that will give us 3 pi over 6, which is, of course, a half a pi. That gives me 4, and I need one more. So plus pi over 6. And then that is going to equal 4 pi over 6. So notice that, by the way, 4 pi over 6 reduces to 2 pi over 3, which is what we wanted, 2 pi over 3. We're going from 0 to 2 pi over 3. So we have split our period correctly. Now we have to figure out how to split this x-axis. So since I mentioned that 3 pi over 6 is a half a pi, and we're counting by 6, if I go here to pi, so half of that distance, so this whole pi, we want to cut from 0 to pi into 6 pieces. So here's halfway. So I'm going to put a purple marker right here. This is halfway in between 0 and pi. Okay? Now we have to cut each of these halves into 3 pieces because I'm counting by 6. Remember, the whole pi from 0 to pi, I want to cut into 6. So I cut it in half. So I have 3 pieces here and 3 pieces here. So you just have to eyeball it. Oh, how about here and here? That looks good. Here and there. That looks good. So I'm just going to do that for right now to get my 1 period of cosine. So remember, cosine starts up. We're going to start up at the amplitude at 0 of 1/2. So there's our first point. Then at our next key point, which is right here at pi over 6, we're going to be back at 0. Every other point is at 0. Then at the next key point here, which is 2 pi over 6, we're going to be down to an amplitude of 1/2. Right there, so we're going to be really squished. And then our next key point here is at 3 pi over 6. We're back up at 0, back to 0. And then here is going to be our 4 pi over 6. So we are back up to the amplitude of 1/2. So that finishes off 1 very tiny period of cosine. So then we are going to continue that pattern all the way through. So I am going to go back and put in hash marks for every 6th. So from pi to 2 pi, that's a full pi. This cuts the pi in half, and I'm going to cut each of these halves into 3 pieces. Same thing on the left side. This is a whole pi, cut it in half, and then I'm going to cut it into 3 pieces. Whole pi, cut it in half, and into 3 pieces. All right, so if I went up 1/2, I'm back to 0, down 1/2, 0, up 1/2, 0, down 1/2, 0, up 1/2. So then that looks like that. And on the left side, if we were up, we're going to go to 0, down 1/2, 0, up 1/2, 0, down 1/2, 0, up a half, 0, down a half, 0, up a half. Woo. All right, and so that looks like that. Not so bad. I'm a little smidgy off on mine, but you'll have to forgive that. Okay, so then let's do our very last one, and then you get to do homework. So for this last one, we have an amplitude of 5, so that means we're going to go up to 5 and down to 5, and then we need to adjust our period. So to find our period, we are going to take 2 pi and divide it by the value that's in front of theta. So we're going to divide it by 1/3, which means that we're going to keep change flip. So 2 pi over 1, instead of division, we're going to multiply by the reciprocal of 1/3, which means we end up with 6 pi. So we are stretching our amplitude way out. So we do need to find our key points. So to find what we're counting by for key points, we're going to take that new period of 6 pi, and we are always dividing by 4. So 4 doesn't go in there evenly, so we're going to reduce that. It reduces, 2 goes into both of those, so it reduces to 3 pi over 2. So this is what I'm counting by. 100% of the time, first key point is 0. Then we're going to add 3 pi over 2. So we're probably not going to get a full period on the right, because we can't get out to 6 pi. We can only go to 2 pi. So we'll only get 1/3 of it. So, but we're still going to do all 5 key points. So 3 pi over 2 plus add another 3 pi over 2. So that equals 6 pi over 2, which there's your 3 pi. And then we're going to add 3 pi over 2, which equals 9 pi over 2. And that gives us 4, and we will add one more 3 pi over 2. So as you get good at these, you can see they go pretty quickly. And then that gives us 12 pi over 2. Now double check, 12 pi over 2 is 6 pi, and the distance from 0, from, why won't that go away? I don't know. All right, well, anyhow, the distance from 0 to 6 pi is our period that we said was going to be 6 pi. So let's mark each of these key points out as far as we can go. So I can mark, I'm going to mark by 1.5 pi's, because that's what 3 pi over 2 is 1.5 pi. So I start at 0, and if I count 1.5 pi, here's my next marker. So you can see this one's really stretched out. That's as far as I can get, is 2 key points. All right, so then we will start, sine starts down at 0. So at our first key point of 0, sine is 0. Then sine goes up to the amplitude at the next key point. So I'm going to go all the way up to 5. So all the way up here to 5. And that's as far as I can go. All right, so then we're going to do our next key point on the other side, which is going to get -3/2. And so if I'm at 0 here, I'm going to go down to the amplitude of 5 on this one, and then fill that in. So that's it. That's what 5 times the sine of 1/3 looks like. So I would like you to try your homework, do the rest of these 4 that are left on this page for homework, and come to class with questions. Good luck.